Welcome to another video here. This is going to be a very short one on celestial distances. So how do we calculate distances from objects? And so as we survey the night sky, one of the key things is we want to find out how far away these objects are. So certain stars, clusters, or even galaxies as a whole. And so how do we measure the distances when we look at these objects? Well, brightness alone is not going to be enough information. If you have two light bulbs that are 100 watts, but one is placed further back than the other, it's going to appear dimmer. So brightness alone is not going to be enough to tell us distances. It's helpful, but we need to find other characteristics. So first way to determining distances, and this is for objects within the solar system, is by radar. So we could use radar, send a signal, see how long it takes for it to come back. So radar is a very efficient way, but it's actually limited to objects that are close by. So probably within the solar system, so within a star system. Second method is using triangulation. We could use a parallax. So again, measuring the distance of a star using this triangulation, having a base system. So this is very basic trigonometry. Having a big enough base system, we could figure out distances here. Now our baseline here would actually end up being 2 AUs. So we would have to measure a star when we're on one side of the sun, then wait 6 months till we're on the other side. Now, if you recall, though, parallax was difficult because of the distance of the stars. So this will only get us so far in measuring parallax. The third step is using apparent brightness of a star's main sequence. So if we look at the apparent brightness and we know what type of star it is, we could kind of calculate backwards what the distance would be. So for example, if we look at two different stars here, let's pretend that we know that this star here is the exact same type of star as this here as well. Well, if everything is the same except for the apparent brightness, then knowing that one star is further back, we know that it's going to be dimmer. So we typically don't look at stars within the same cluster though, but we could compare this star to kind of just a general catalog, and we could recalculate backwards how much fainter it appears, so how much further back that distance must be. So we'll be able to kind of, knowing a star's cluster distance, we can determine luminosity, but we could use that backwards. Knowing the luminosity, we could find out that distance. Another method for objects a bit further out would be Cepheid variable stars. And so looking at the main sequence, these stars are extremely bright, so they're easier to detect. And their light curve tends to peak at the same amount. So we see that these peaks here occur at the same apparent brightness over and over. So they're more periodic. They stand out a little bit easier for us. And we see that actually those that have a longer period tend to be more luminous as well. So these are kind of what we call standard candles. And so they help us out to be able to detect that distance. And then another way to detect distance for objects that are further out, now we're talking at about 10 billion light years or so, is another standard candle, but we use supernovas. So if you recall, supernovas have a lower limit, right, of what those stars are going to at the end of their life. These high mass stars will end up just blowing up at a violent explosion, but because of their mass limit, these explosions tend to be at the same peak, and these are extremely bright. So if we're trying to find out distances now of galaxies, looking at these supernovas as standard candles will help us out. Okay, well, that's a short video here on some methods to detect distances, which is one of the difficulties of detecting or characteristics of objects in astronomy.